Hello class, this is Mrs. Albritton of Albritton's math class, AMC. So this is part 3 of our study guide / practice test for our right triangle trigonometry test that's coming up. So we're going to do number 11 through 15, the last 5 problems. Number 11, so right triangle RST is shown. If sine alpha is equal to 4/5, what is the value of cosine beta? Now, given this information, because if you notice, we don't have any information on the triangle with the side lengths, but we're told that the sine of angle alpha, so from here, is 4/5. Sine tells us that we are looking at, and this is of alpha, we're looking at the opposite side over the hypotenuse. And in this case, they tell us the opposite is 4 from angle alpha, and the hypotenuse is 5. Well, here's the hypotenuse, so that's going to be 5. And the side that's opposite angle alpha is straight across, directly across, so that's got to be 4. The question, what's the value of cosine of beta? So this is angle beta, and keep in mind that cosine is adjacent over hypotenuse. So from angle beta, I need to look adjacent, which is beside, so 4 is beside it, and the hypotenuse is still 5. So the answer is going to be 4/5 for cosine beta, the same as sine alpha. Let's take a look at number 12. Here's problem number 12. And this is similar to one of the problems that we had previously on this assignment. In the diagram below, triangle CDE is similar to right triangle ABE. We're asked to select all the ratios that are equal to cosine of angle E. So what I've already done is I've actually separated those two triangles so we can see them a little more clearly. So here is CDE, the smaller one, and then here's ABE, the larger one. So in order for us to determine which one of these are equal to cosine of E, let's go ahead and determine the cosine of angle E for the smaller triangle. Remember, cosine is the CAH. Cosine is adjacent over hypotenuse. So we're looking at the adjacent side over the hypotenuse. And we're looking from angle E. So if I'm looking from angle E, I already know that my hypotenuse is this side, ED, or you could reverse that and say DE, segment DE. So my hypotenuse is, let's put ED, and we could also write it, I'm gonna put we could put DE, so let's do that. And then for the adjacent side, well, the adjacent side is going to be CE because they didn't say opposite. Opposite would be CD, straight across. So this is adjacent, CE. So we've got CE. Sometimes you'll see it, we can actually reverse those alphabet and get EC. So we can write it either way. So that's the smaller triangles, cosine of angle E. Let's do the larger one now. So same thing, we've got the adjacent over the hypotenuse for the larger triangle. So this time, the hypotenuse is going to be EB, so I'll put that there, or it can also be written as BE. Now let's get the adjacent side. Well, from angle E, adjacent is AE, which can also be reversed, and you can put EA. Because it's not AB, because that would be opposite that side. Now let's see which of these are equal to cosine of E. So here we have AE over BE, so we could use this one right here. This is an answer, because remember it's AE over EB, but you can flip-flop this and call it BE, so that matches. CD, well, none of these have CD on top or DC. So none of those fit. This won't work. All right, BE on top. Nope, I don't see any BE as the numerator, so that won't work. AB as a numerator. I don't see any AB on any of these, so no. How about CE? Yep, we have CE over DE. Yep. This one has ED, but you can flip-flop it. So don't let all those switching of the alphabet throw you off. So this one will be an option. And then do we have a DE as one of our numerator values or top values? We don't. So this won't work. So there's only two that are equal to cosine of E. Okay? Number 13, triangle LMN is shown below. If sine of angle alpha is equal to the square root of 3 over 2, what's the value of cosine beta? And this is similar to one that we did earlier also. So again, we have sine, and we know that sine is the opposite, well, of angle alpha is opposite over hypotenuse. And in this case, our opposite is square root of 3. Our hypotenuse is 2, so let's label that. This is 2, and the opposite side from angle alpha, which is directly across from there, is the square root of 3. Now that information is going to help us find the sine of angle beta, which is still going to be opposite over hypotenuse. I'm sorry, we want cosine for this one. So in this case, they're switching it up. We want the adjacent side over the hypotenuse. So the adjacent side from angle beta is going to be the square root of 3. The hypotenuse is still 2. So in this case, we end up with the same ratio, square root of 3 over 2. There's your number 13. Problem number 14. In the accompanying diagram of right triangle ABC, the hypotenuse is line segment AB. AC is 3 inches, so this side is 3 inches. BC is 4 inches. And AB is 5 inches. And again, AB is the hypotenuse. The question wants to know which of the following is equal to the sine of angle B. So first of all, let's identify the sine of angle B. Now remember, sine of angle B is going to be the opposite side from angle B over the hypotenuse. And in this case, from angle B, the opposite side is 3. The hypotenuse is 5. So we're trying to figure out which of these is the same as 3 over 5. So we got to check each one. Let's check cosine of A. So from A, remember now for cosine, we're looking at adjacent over hypotenuse. So let's check it. If we're looking at angle A, adjacent from A is 3, and the hypotenuse is 5. Okay, that seems to be our solution. All right, we are done. Let's get number 15. All right, let's do the last problem, number 15, from our study guide / practice test. In the diagram of right triangle ABC below, what is tangent C? And so we need to just recall that tangent is the TOA part of SOHCAHTOA. Tangent is opposite over the adjacent. And this is of angle C. So we're looking for the opposite side of angle C over the adjacent side of angle C. And let's find that. So here's angle C. The side that's opposite, directly opposite, is this side, which is 2. And adjacent is 3. Now, why is it not the square root of 13? Because that's the hypotenuse. This is the opposite side. This is adjacent. And of course, we all know that this is the hypotenuse. And tangent does not deal with the hypotenuse at all. So tangent of angle C is 2/3. All right, and that concludes the video for your study guide / practice test for your right triangle trigonometry test. Good luck.